Alright, in this video we are going to continue with our statistics, and we're going to learn to display categorical data with a bar graph and or a segmented bar graph which replaces a circle chart or a pie chart. Decide whether it would be appropriate to make a pie chart, which we wouldn't make anyway, but identify what makes some graphs of categorical data deceptive. Distribution. Now, a distribution tells us so a distribution tells us the values a variable takes on and how often it takes on each value. Okay, so an example might be, if we're looking at M&Ms. Now we know they have blue, they have red, they have green, they have brown, and they have other colors as well. But you might say these are the distribution. Maybe there were 11 blue and 10 red and 7 green and 14 brown, and so on and so forth. That would be a distribution of the colors of M&Ms. So let's look at making a bar graph. What do teens post? Here are the percentages of 12 to 17-year-olds who post various types of personal information on their social media profiles, according to the Pew Internet Parent-Teen Privacy Survey in 2012. So type of personal information: photo of themselves, 91% do that. School, 71%. City, 71%. Email address, 53%. Cell phone number, 20%. I'd like to make a well-labeled bar graph to display data. Describe what you see. Okay, so let's make a bar graph for this information. First of all, we have to label it. We want to put down here type of info. And we have 5 types. We have a photo. We have the school. We have the city. We have the email. And we have the cell number. And over here on this side, we're going to put the percent. So we're going to label this 10, 20, 30, 10, there's 30, 40, 50, 60, 70, 80, 90, and 100 at the top here. And each one's going to get its own separate bar. So this would go to 91%. I like to write it in there. The school goes to 71%. The city also goes to 71%. Email, 53%, right about here. That's right, 71, 71, and 53. And then 20% for the cell phone number. About 20%. That's a bar graph, well labeled. Okay. Now the second question, would it be appropriate to make a pie chart for these data? And so the solution to B is no, because the percents do not add to 100. And remember, if you're going to make a circle chart, which I wouldn't do unless I had Excel, each person can only fit into one category. Now, if we wanted to make a pie chart of our blue, red, green, brown, we could do that because each M&M is only going to fit into one category, and we can calculate percentages that would add to 100. But they do not do that here. Okay. Now, we're also going to make what's called a segmented bar graph instead of a pie chart. These are much easier to make, and they give the same exact information with a lot less work. So we're going to do that. So here's how we're going to do that. We're first going to come up with this. These are the frequencies. We have a distribution of cell phone type for 18 to 34-year-olds, 517 of them. Frequency is just the count. How many did each thing? We're going to calculate now the relative frequency, which is the percent. So that would equal 169 out of the 517 people owned an iPhone, which is about 33%. Android, 214 out of 517, which is about 41%. And finally, the other 134 people out of 517, and that's about 26%. So we had to calculate the percentages in order to make the segmented bar graph. So the way we make this segmented bar graph is we are going to draw and label. The percent goes on the side, and we still have to do 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 at the top. This time we make one big bar graph, and it goes all the way to 100%. And it's one bar, and we're going to each little spot is going to get its own segment. That's why it's called a segmented bar graph. So first of all, we have to have our label on the bottom here. This would be cell phone type. And we start with the biggest. So the biggest one is Android at 41%. So I'm going to make a line 10, 20, 30, 40, all the way up here. 41 is about right here. It's about 41. And that's Android at 41%. The next biggest one is iPhone at 33%. So what we need to do is we're starting at 41, so we do 41 plus 33 is 74. So we're going to end this one at 74%, right about here. So this is iPhone at 33%. And other is the only category left, and it takes up the remaining 26%. That's how we make a segmented bar graph to display the data. You can see how quickly that went without having to make a circle graph, which is much more complicated to make. Okay, so how to identify bad graphs? Sometimes graphs are not well made. In 2008-2009 regular season, basketball player Dwayne Wade averaged 7.5 assists per game and 2.2 steals per game. Explain what is wrong with the following graph and how to make it better. Well, number one, when we look, we can see that the height of this basketball, wherever as assists, looks about halfway between 5 and 10, which would be 7.5. So certainly its height is correct. And the height of this ball, come across, a little bit less than half of 5, which is about 2.2. That would be fine. Those heights would be fine. So what makes the graph wrong? Well, if we did this with a bar graph, we would have a bar that went up to 7.5 like this. That would be for our assists. And over here we'd have a bar similar, but like that. Now the thing about the bars is they are the same width. Even though one's taller, but they're the same width. Whereas this basketball, this big basketball here is, not only is it taller, it's also a lot wider. So it makes it look as though the disparity is a lot more. Because if you take 7.5 and 2.2, that's about 3 times bigger, a little more than 3 times bigger. But this basketball looks about 8 or 9 times bigger, and that just doesn't work. So really you have to beware of pictographs. If they're not used correctly, they can make the graph misleading. The graph really is misleading. These bars don't have near the disparity that the basketballs do, and it makes it look like he really has a super high amount of assists compared to steals.